aerobic training. With this type of training, we're using oxygen. We're going to use that oxygen to help generate our ATP. So these types of activities tend to be moderate in intensity, something that's repetitive and continuous over 5 minutes will have the aerobic system supplying most of the energy. Normally use carbohydrate, so carbs as our main fuel source. So like if we were out running a marathon, we would run carbohydrates, and if you've ever heard of somebody hitting the wall, it means they're starting to tap into fats as an energy source because they've used up all the available carbohydrate, all the available glucose, and they start using fats, and it's less efficient, or it takes a little bit longer to use fats as an energy source, and they start hitting the wall and getting fatigued, and it's a much slower process. So that typically happens in long distance aerobic events. Somebody can hit the wall. So if you've ever heard somebody hitting the wall, that refers to using up all your carbohydrates and having to tap into fats to generate your energy. So if you wanted to link this to an energy system, this would be the aerobic, it's a C there, aerobic oxidative energy system. And I talk about that in other videos where we link the health related components to the various energy systems. So that's going to include aerobic glycolysis and the Krebs cycle. And the electron transport chain. So here we're netting about 2 ATP. We're netting about 2 more ATP here. And here we use NADH and FAD to generate about 34 ATP. So the NADH generates about 30 ATP, and then the FADH will generate about 4 more ATP, and then it adds up to about 38 ATP. And ATP is our chemical energy. It's kind of like gasoline for the body. That's a 38 right here if you can't read it. I'm not going to go too far into that because I've made several videos about it, and it kind of breaks it down, but this would be substrate level phosphorylation right here that happens in the glycolytic or glycolysis. That's an S right there. Sorry, kind of hard to see. Glycolysis. And here in the Krebs cycle, that's also substrate level phosphorylation. That's where you're breaking down, or substrate phosphorylation, where you're breaking down through glycolysis in the Krebs cycle. You're breaking down something like glucose to generate your ATP. And in the electron transport chain, it's oxidative phosphorylation. So a little different here. This happens directly. So you're directly generating your ATP by breaking down glucose. And here you're indirectly generating ATP using NADH and FAD to indirectly create your ATP, and that's a whole nother video series. I'm not going to go too far into that. You can watch the videos about the electron transport chain if you want to know more about that. So let's talk about muscle fiber type real quick. So if all you ever did was aerobic training, you're going to develop more slow twitch muscle fibers. And most of this is based on genetics, but you can alter your muscle fibers by doing one type of training over another. So these are type 1 type 1 muscle fibers. So slow twitch or type 1 muscle fibers, they have a lot more blood supply, myoglobin in them. There's a lot more blood supply to them, more capillary innervation. So we'll talk about the different muscle fiber types in another video, but if all you ever did was aerobic training, let's say you run marathons a lot, you're going to have a greater percentage of slow twitch muscle fiber, whereas if you lifted really heavy weight, you're going to have more fast twitch. And then there's another intermediate fiber, but we won't talk about that right now. So types of training, there's many forms. So for aerobic training, many forms. You could do like circuit training, you could do your standard aerobics. Most of them are going to be moderate intensity. It's not saying you won't ever hit a high intensity, but most of them are going to be moderate intensity. It's just the higher your intensity, the harder it is to maintain, so you're not going to go for very long if the intensity increases. These tend to be continuous and repetitive over a long duration of time. So you could do something like circuit training. So there's various forms of circuit training. So if you were in a weight room, you could just go from one machine to the next, and you can make that aerobic by not stopping. You could do the same type of circuits training. Some people call it station training with body weight. So if all I did was lunges, push-ups, and sit-ups, and I just went from one to the other where the muscles would have time to recover, I could make that aerobic. I could do that for 20-25 minutes. It'd get really boring. I mean, you'd want to have more activities, but you could make a traditional anaerobic exercise aerobic if you'll join them together and hit different muscle groups so that you can allow the other muscle groups to recover. And I do that a lot in classes where I kind of break up the monotony, and it's good to kind of cross-train. You could go out and just run. That would be a form of aerobic training, running long distance. You could walk. That's just lower intensity aerobic training. If you had any kind of pre-existing injuries, walking would be good. You could get on an elliptical and do some sort of exercises. You could do traditional aerobics, kickboxing aerobics, you name it. So there's a bunch of various forms of training, all with various ranges of intensity. So a lot of times when you're talking about the aerobic system, it's important to understand aerobic capacity. And again, this is an area I'm going to make a separate video on, so I'm just going to kind of touch on the subject. So with aerobic capacity, we have like the heart, lungs, and blood vessels. All working together for aerobic capacity. In a way, most exercise physiologists will measure this is using VO2 max, and all that is the volume of oxygen over time that you can upload to the tissue. So how much oxygen, how efficient are you at getting oxygen out to the tissue? Normally for the average male it's 35 milliliters of oxygen per kilogram of body weight per minute. So this is actually O2 here. So we got 35 milliliters of oxygen per kilogram of body weight getting out to the tissue. So that's how efficient the average male is. For the average female, it's 32 mLs per kg per minute. And that's how you'll normally hear it referred to. And we'll talk about this in a separate video. We'll go in and look at elite level athletes and kind of look at their VO2 maxes. The highest ever recorded VO2 max is by a cross-country skier, and that should make sense because they're using upper body and lower body exercise, so they're not just doing lower body aerobics, they're including the whole body, so they have to have a really high VO2 max. So this is for the average male. Let me go over that one more time. This is 35 milliliters of oxygen per kilogram of body weight per minute. So that's the volume over time of oxygen you can get out to the tissue. How efficient are you at using oxygen? So as that number goes up, you become more efficient. And we'll talk about that later in a separate video. Some of the benefits of aerobic training. So here we have some benefits. Lower mortality rate. So lower mortality rate, and a lot of this is just because of the decrease in hypokinetic disease. It's a T there. Hypokinetic just means low movement. You're sitting on your butt too much. You're not moving around. So hypokinetic disease can be high blood pressure. So high blood pressure, your blood pressure is too high. Diabetes as a result of hypokinetic disease, not moving around enough. Heart disease, you name it. There's several. So another benefit is increased mitochondrial density in the cell. So you're going to increase mitochondria, or the density of mitochondria in the cell. So they're going to go up. So the more mitochondria you have, the more aerobic you are. So that's the reason our Olympic Training Center is at altitude, is to help increase mitochondria, and exercise will do that as well. You're going to increase the size. So you're going to increase the size of the left ventricle. So the left ventricle of the heart is going to increase, so it's going to get larger. And you're going to increase stroke volume. I'm just going to write SD for that. And you're going to increase cardiac output. So stroke volume is how much blood the heart can fill up per beat, and cardiac output is heart rate times stroke volume. So how fast the heart is beating, how much it's filling up with blood, equals cardiac output. So that's how much blood you can get out to the tissue. So that goes up as well with aerobic training. And then you have improved circulation, and that's really where we get the improvement in blood pressure. So circulation improves, and you have more capillary innervation. And all that means is just the smaller capillaries, which are like the smallest arteries in the body, kind of innervate, kind of go through the tissue. There's a lot more blood supply to the tissue is probably the best way I can explain it. So a lot more capillary innervation, a lot more blood supply. And that should make sense, because if you have more slow twitch muscle fibers, so if you have more slow twitch, you're definitely going to have more capillary innervation. And so that's the benefits of aerobic training. Let's go back over some of this real quick, and then I want to touch on something else before I stop the video. So aerobic training in the presence of oxygen, so we're using oxygen to help generate our ATP, something continuous and repetitive for about 5 minutes, but it's got to be moderate intensity. If the intensity gets too high, the anaerobic system has to kick in, and we're not purely aerobic. So a lot of times that happens during interval training. Then carbohydrates are our main source of fuel. And we're using the aerobic oxidative energy system to generate our energy, which is including aerobic glycolysis, the Krebs cycle electron transport chain, to generate about 38 ATP. And then our aerobic capacity, if we do aerobic training, of course, is going to increase, and that's the heart, lungs, and blood vessels all working together. And we measure that through VO2 max, which is the volume of oxygen that we can get out to the tissues, so how efficient we are at using oxygen. The benefits: lower mortality rate, and that's mainly due to the decrease in hypokinetic diseases like high blood pressure and diabetes and coronary artery disease and stuff like that. Mitochondria will increase inside the cell, so those are our powerhouses of the cell to help generate more ATP when we do aerobic training. The left ventricle of the heart becomes larger and more pronounced, so therefore it can pump more blood per beat. So there's our stroke volume. Not only it can fill up with more blood, that's the stroke volume, it can pump more blood per beat because it is stronger, so it can pump harder, so the heart rate goes up, and then stroke volume increases, and then cardiac output increases.